Hello everyone, welcome to today's presentation on specification and construction of granular subbase. As the name indicates, subbase, it is below the base course layer. In the cross section of flexible pavements, we had seen it is the layer which is above the subgrade and below the base course, that is sub base course, above subgrade and below base course, and this acts as drainage layer also. If we are not providing any separate drainage layer, this acts as an drainage layer. That's why this GSP layer should be laid over full width of the prepared subgrade and extended up to the side drains. And main objective of providing this GSP, or I can say the important functions of this GSP, is to serve as a structural component of flexible pavement structure by distributing the wheel load stresses transmitted through the surface course or the upper layers granular base course uh, to its to a large area before uh, passes on compressive stress on the top of the subgrade. Before it passes to the next layer, it need to distribute, right? That is acts as a structural component. And the second one is to serve as an effective drainage layer, to drain off the water entering into the pavement layer, leading to longitudinal side side drains, right? So these are the main two objectives of GSB, granular subbase. So this GSB come drainage layer serve as an essential component of flexible highway pavements. That is most important, right? Because most of the highways fail because of improper drainage. Hmm? But in case of a rigid pavement, if we speak, this GSP layer serves only as an effective drainage layer, as most of the load stresses, the magnitude of load stress is transferred is transmitted on the GSB layer is almost neglected because of the slab action of the rigid pavement, right? And we'll see the materials specifications of this GSB, specifications of the materials. So what are the materials which are generally used as an granular subbase layer? It may be uh, crushed stone aggregates, what we can see in the right corner, crushed stone aggregates, or it may be a gravel, or it may be muram, and it's most common red soil, muram, and the coarse sand also can be used. Okay, so these are the four materials we see. Apart from this, when we say muram, it should not be any red soil. It should be have less fines and very low plasticity values. The different gradations of GSP materials is suggested in the MORTH specification. MORTH is Ministry of Road Transport and Highways. Under this, they have specified the certain requirements of the uh, material which we want to use as an GSP layer, right? So main requirements of these materials is that is, if it is passing for 25 micron sieve shall have a liquid limit less than 25% and plasticity index less than 6%, and fines passing 75 micron should be less than 10%. And that's why I mentioned the fine should be less in case of Muram. And the CBR value not less than 30% for important highways or where heavy traffic is there, and not less than 20 to 25% in case of other type of roads, right? Based on performance studies of flexible payments in several parts of the country like India, it is found that the desirable it is desirable to select the material of GSP cum drainage layer which fulfills the requirements what we have mentioned, that is proportion of fines passing 75 micron to be minimum, should not exceed 5%. It should not exceed 5%, and the plasticity index it should be less. In the earlier we have mentioned it is 6%, but if it is near to 0 it is very good, right? And coarse grained material which acts as a good drainage layer because of coarser aggregate coarser sizes, good drainage characteristics with the high permeability in other words, that is there will be more number of voids, and because of which it acts as a good drainage layer. And it is specified in the tables here. What we are seeing is grading for close graded granular subbase, grading 1, grading 2 and grading 3, which is passing through 75 mm, 53 mm, 26.5 mm, like that. Sieve sizes are given in the left first column, and they have mentioned the CBR minimum CBR values for different gradation 30, 25 and 20. So as the coarser gradation will be there, the CBR required is higher, and yes, definitely it is possible, and it provides good drainage also. And the second table here, it is grading for coarse graded granular subbase material, percentage of different grading 1, grading grade 2 and grade 3, that is closely graded, it is mentioned. And the certain physical requirements which we already discussed. Now coming to the construction operation, before laying the subbase, the subgrade should be prepared by removing vegetation. It is quite natural that during construction process will uh, prepared a subgrade. If it is open for more period, then there will be definitely vegetation, so that vegetation need to be removed, cleaned properly, and then we can go for the construction, that is spreading of the GSP material. And need to check the moisture of the subgrade material. The subbase material is spread uniform with a uniform thickness, and specified cross slope also need to be maintained using the mortar grades. So whatever I can see here is mortar grade is there. Using adjusting its blades, we can spread the granular subbase material on the subgrade layer. The moisture content of the material is checked, and additional quantity of water that is also sprinkled, and that is also sprinkled with the help of these tankers fitted with a sprinkler in the rear, and the help of truck mounted sprinkler can sprinkle the water, and at a uniform rate, and optimum moisture content need to be maintained. The water material is mixed properly using machinery such as I'll just show this in the next slide. Yeah, here that is harrows are rotors. Using these machineries, these will rotate and uniformly mix the uh, sub-base material. Hmm. This mixed material is again spread to desired thickness, grade, and required camber. Hmm. And the motor grader with whatever hydraulic connections need to be spread properly. Then we will use the rollers. Now movement of these rollers also is very important. That is the loose GSP layer is compacted by rollers. If the compacted thickness of layer is 100 mm or lesser, if it is single layer with a 100 or lesser thickness, an ordinary smooth wheeled roller may be used for compacting the thickness. For compacting 100 mm to 225 mm the GSB layer, we can use a vibratory roller, a static weight of around 10 tons or more, or we can go for the pneumatic tired rollers whose weight is also more. Here you can see pneumatic tired rollers for appropriate gross load or a tire pressure may also be used. If this type of material selected can effectively compact with the help of these kind of equipments, or you can go for the two drum vibratory rollers. And the roller is this rolling is done starting from the uh, lower edge and uh, need to proceed towards the center, especially for an undivided carriageway, or towards the upper edge. You can see in this diagram towards the from inner edge to outer edge to towards inner edge, with a minimum 1/3 overlap between each run. And the roller speed is limited to 5 kilometers per hour. And this way I mentioned here the roller, what should be the roller speed, tonnage and all. 5 kilometers per hour. Till what point the rolling is continued till 98% of maximum dry density of the material need to be achieved for heavy compaction as per IS 2720 part 8. And once the densities required densities are achieved, then we need to cross check also. Now coming to the quality control checks during the construction of granular subbase, and that is the quality. It is very important whether you are constructing in single layer or multi layers. The representative sample of GSP is collected from each sources that is subjected to relevant laboratory tests, which I mentioned earlier, that is with respect to liquid limit, plasticity index, percentage of fine, CBR value, that also need to be checked. Gradation, and if some particular source of is not suitable for the required gradation, then we can go for the combination of these gradation materials. Second, that is laboratory compaction test. As per the Bureau of Indian Standards, heavy compaction is carried out to determine the OMC and maximum dry density. The CBR values of the selected material is determined in the laboratory. The field moisture content of the material is determined prior to the compaction by any rapid test method, or extra quantity of water to be added to bring up the optimum moisture content is estimated. And after rolling on field, the field the field density and moisture content are determined by one of the appropriate methods to ensure that the dry density achieved is not less than 98% of laboratory density. So these need to be repeated, means checking the OMC, checking the density till we achieve the required density. And the finished surface level of the sub base cores are checked with reference to the desired longitudinal or cross profile of road, which are given in the with respect to the drawings which are provided, with respect to whether the finished surface and level RLs need to be checked. And if these are found to exceed the permissible tolerance of generally the tolerance is minus 20 to plus 6 2 centimeter to 5 centimeter, sorry,